Alright, this one was an easy question. It's supposed to be an easy question. All I have to just check is, hey, if there's something that contains I minus 5 exist, if I minus 5 exists, maybe use that as a key in this. Tell me, please. But here's the problem. I just realized. Um, in a given array of positive integers A and B, find and return a continuous subarray. We have to return the continuous subarray. So this don't work. This really don't work because I have to return a subarray. So let's just go ahead and restart it and come up with a goddamn actual result that will work. Alright, first of all, TL draw, awesome as fuck. Highly recommended. Um, Alright, description. Okay, you've got an array where the second argument given is an integer. We have to find if it's equal to that integer. Yeah. Cool. So we know. Okay, what can we kind of derive this from? What is something similar that we have done? We have done something similar where we had a what the fuck is going on? I don't like this. Why is this not thick? Oh, I wanted 100%. Give me 100%. Yeah, there we go. Okay, this is better. So earlier we had a particular subarray of type. So we had this like subarrays where we had to find if something was equal to 0. So it could have negative numbers, and we had to go ahead and say, hey, if this subarray is equal to 0. So if it was 0, we could basically just go ahead and say, hey, we have a let's duplicate this, and we're gonna go ahead and start working on it. We knew if let's say 2, 3 minus 5, 4. So then we took a prefix sum where we go 2, 5, 0, 4. If it's 0 came up, then we know the prefix sum. But at the same time, if 5 came up again, we knew that, hey, the prefix sum was going to be, because of the prefix sum, we knew that it's going to be the same. Now, how can we use something similar to this and come up with a particular way to kind of find that? Now, let's look at the constraints as well. The length of the array is about 10,000. A to the power of I is 9, so we kind of have to still come up with an O of n option. Because 10 to the power of 6 is still 1 second. So going into 2 loops will be a bit of a pain. But yeah, we'll still look at the brute force approach as well. I'm gonna at least try and come up with something for it. Return the first contiguous array. So we have to find the contiguous. That kind of gave us the contiguous array for sure. Because it will go like, oh, 0 to 0. Because it starts from 0. Oh yeah, because it starts from 0. I could have given that as an example. Ooh, so it'll be 0 to 0. So this will go from, yeah, whatever. So how do we, so we also know that if in a prefix array, because the effective is null, we know that, hey, there exists kind of like a sum which is 5. Right, so the first condition is if 5 is present in a prefix sum. Okay, we're good. But we also mean that, so we also need something to in the prefix sum to go like, huh, we have a sudden difference of 5. Okay, that's one song to kind of go ahead and say mess with me. So can we do something in the prefix sum where rather than checking, hey, if like a key exists already, so with earlier, so let's go back to that problem. Let's go back to that problem. All right, we've got that facility here. We can go back to the problem. It's in the all problems which I've already solved. Subarray with a given sum attempted. No, not all problems. Give me solved. Rotation matrix pointer, shaggy distance. Subarray sum is 0. There we go. Subarray sum is 0. This has to be been done with hashing. Yes, it was. So we found a poster sun, and blah blah blah. 0 starts from this. We created post view. Then we created a hash map of long type because this could be long. And then we check if one, it contains 0. If a map contains the uh, whatever prefix sum already existed. But we know that the effective value in this case, if it was 0 for 0, it has to be plus 5 for that, right? So let's take the example array over here, which is a good one. Okay, and we will go ahead and go down, down, down. We'll make this bigger, all right, and we will now come up with a prefix sum array, which will be okay. I'm sorry, I'm beautifying because this helps me think. And if I'm going in the wrong way, so that means the prefix sum over here would also include 1, 3, 5, 1, 2, 3, 5, 5, 6, 7, 8, 9, 9. Wait, what? Am I an idiot? N into n plus 1 by 2. So n over here is 5. So 5 into 6 by 2. 6 into 30. Oh, that's the sum. Yeah. 2 further 2, 2 further 10, 15. Yeah, I'm doing something wrong. 2 plus 1 is 3. 3 plus 3 is 6. I'm an idiot. 6 plus 4 is 10. 10 plus 1 is 15. Yeah, there we go. 15. Alright. So what we can do over here now is, because it's 6, so what we can do is, we know that 2 and 3 is the array, right? Now, if we were looking at the 0 effective, we knew that I minus 1. So we knew that, hey, that I minus 1 to j here will be the array, right? Am I right? Oh, I didn't return that subarray. Whatever, doesn't matter. We've got the point across, okay? We've got the point across. So we need to be able to go ahead and say, hey, if the effective increment between them is 5, that means there should be a value in the prefix sum where minus 5 exists, right? So if we say, which should be I plus 1, to be honest. Like I plus 1 should exist, right? So where the idea is, okay, so let's say 6 minus 5 is 1. Now we know 1 exists, so 3 to 6 should be the answer, right? Okay, do we have another good example for this? What would be another good array where the prefix sum would be 5? Okay, let's just rerun this logic on another prefix sum array. Oops, sorry. Oh, my bad. Okay, in another, and this time I'm literally going to take a random array size, leave it here because I don't want to be too big, and I'm going to put. I don't even know, 1, 2, 3, 4, 5. Okay, so we need an array which will be equal to 5. So what will be, are there negative numbers here? In the constraints do not have a negative number. Foik. So that means we can only have, let's say 1, 2, 3, 4. Let's make a 4. Let's make a 4 plus 1 plus 1 plus 1. Okay, 4 plus 1 plus 1. No, wait, 3 plus 1 plus 1. Okay, 3 plus 1 plus 1, 2 and 1 here. Actually 4 here, 2 plus 1. Okay, so we've got 3 plus 1 plus 1. So the first subarray should be this one. Fuck. So make this 4 again. Okay, let's make this 4. Okay, so it's 3 plus 1 plus 1. This is the first subarray. Okay, so we will go ahead and create another prefix sum. Okay, stop pressing control, Jabir. You don't have to always be in control. Okay, so I'll make the first prefix sum. We're gonna go ahead and go chungus, 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 chungus. Okay, fine. We're gonna go ahead and say, hey, the first one is 4, so the first value will always mean 4. 4. So of course in the hash map, like in the hash map, also we can put 4. It doesn't matter. 4, 5, 6, 7. 4, 5, 6, 7. 7. Okay. Uh, okay. 7. 8, 9, 10, 11, 12, 13. So this will be the prefix sum, right? 4, 5, 6, 7. 7 plus 1 is 8. 8 plus 1 is 9. 9 plus 4 is 13. And we start now putting 8 in a hash set. I think will be a better idea because we don't really care, right? We have to just find the first one. So we can put it in a hash set. No, we cannot put it in a hash set because we do need the index. Okay, so we go ahead and say, like, hey, in the hash set, hey, is there 5 minus 4 present? Say the number is 5. Okay, let's take b is 5. We're taking it in a way that it just makes sense for any number, including 0. Yeah, right? Yeah, including 0. Um, so the number itself should also count in the array, whatever. Um, okay, yeah. So let's just take 5 right now. Okay, so we know. Okay, does 5 minus 4 1 exist? Nope. Just put in the hash map at index 0. Okay. Does 7 minus 5 exist? 5, 7, 5, 6, 7. Am I an idiot? No. So 2 does not exist, so it's fine. Put 7 in the index 1. Okay. 8 minus 5. Does that exist? 8 minus 5 is 3. Does not exist. Yeah, 3 does not exist. So put 8 at index 2. 9 minus 5. Does that exist? 5, 6, 7, 8, 9. 4. It does. Wait. 4 does exist. This is at index 0, 1, 2, 3. So we know the third index it should return and the first index, which means that the subarray final should be, so we should return from the first array 3, 1, 1. Oh, I'm a genius. Okay, now let's just write the logic for this. Okay. I just called myself a genius for an easy ass problem. That's questionable behavior. Alright, first one. Can we do this in one go without making a prefix sum? Like what I did over here, I did 2 loops, right? I mean, it's allowed. I should not be too worried. Because then I'll have to anyway do another loop to, so I can just say, hey, while you're making that particular thing, you can also make the prefix sum. So you can do 2 things at once. Because you have to anyway go through the hash set in order of n, I could put both of these operations in the same loop and not have to create incredibly additional space. So like I'm creating over here a possibility in the worst case scenario of n squared space because I'm creating a prefix sum array and a prefix sum hash map. So what can I do? Okay, so let's take A is the array, B is the number, of course. So we'll write an int n, which is equal to a dot length. So what we will do is go from for 0 to n, the I is the index here. What we can do is we can go ahead and say if I is equal to 0, then oh no, I cannot do that because hash map is unordered, so it does not give a damn. I will literally have to create a prefix sum array. Oh, I see. That's why I did that in two operations, not one. For those of you who don't understand, it's not gonna happen that um, I can like get the previous index and the same. So I'll have to literally create a prefix sum array and then work my way forward into a hash map. Okay, fine. We know how to make a prefix sum array. Make prefix sum array. I'm not gonna go ahead and explain that. Then check hash map. Create hash map from I0 to n. 0 to n. What we will do is from there we will go ahead. This giving me infinite space was a horrible idea, man. TL draw. You giving me infinite space was either was a horrible idea because I'm pretty sure I will lag this thing one day. And yeah, whatever. All right. Where was I? Where was I? Where was I? Where was I? Yes. So from I to whatever, and if contains key, where key will be a of I minus B, then return whatever. Else put. Not also logic, because I'll have to actually create a resultant array. Because yeah, okay, makes sense. Let's do it this way. Let's make a prefix sum and let's fuck around with it. I'm gonna copy that code from here, by the way. I'm not gonna. There is some simple code that I can copy, so I'm just gonna take that from here. I'm not gonna waste too much time on that part of the code. Um, why am I making a long? Because the numbers can go really large. Like taking consideration that a of I can be to 10 to the power of 9, 10 to the power of 9, 10 to the power of 9. So we're gonna do that. Yeah, hash that long hash map, and that can also be copyable. It's fine. I have to just change. I have to literally just change basic values. This is like literally the same code, just changing basic values. Um, a little bit of logic, which we will work on right now. So we're gonna do this again. We're not gonna do return. We're gonna do over here. In this case, of course, we're gonna return -1. Um, if p of I is equal to b. So if it's directly equal to b, what do I want to do? Because this is the case in the zeroth problem where you can go ahead and counter 0 at the first. So say that means the prefix sum starts from the 0th index to that ith index, right? So so we have to return it from that 0th index to the ith index. Okay, so that means like that's the minimum subarray. So we're gonna go ahead and also we're gonna create an int result of type whatever, and we're gonna go ahead and here say result is equal to new. Let's just say if p of I is just straight away equal to 0, so this is what will happen. So we want to return the array from that size. Um, so it'll be of size I, of course, uh, which will be the main size. How do I do this again? Did I forget syntax is in the middle of a live stream? That's beautiful. So what we were gonna do is we're gonna create, hey, res is equal to new int of size I for int j is equal to 0, j is less than I, j plus plus, res of j is equal to a of j. A of j and return res. Okay, so this will comprehend the situation. Hey, we've got b, found it from in between the element So it's like it'll take care of the condition where there's an array of 2, 5 is just here, so just return the 5. That's the first subarray. It doesn't matter. But I should really check the question. First subarray, right? Yep, just return the first subarray. If it doesn't exist, it doesn't matter. If given an array, positive integer A and B, find and return the contiguous subarray. If it doesn't matter, then first subarray, blah blah blah. Else the wrong question. Yeah. First subarray, which means the subarray for which the index is in the minimum. So minimum index is fine. So we have to just return the first subarray. It doesn't matter. For 0 and 5, it'll return. I'm gonna remove this now. I don't need that. So it'll go from here. Just go from 0 to I. We're good. We're healthy. We're cool. We're crabby. We're gonna go till I, and we should be fine in this case. Where okay, fine. Made the result. It was of size I. Good. Return. Mwah. Beautiful. Okay. Now we go over here. What does this case do? We go ahead and say, hey, this is. So we're gonna go ahead and actually I'm gonna create a int s here because this is the condition where I've actually found ps of I minus b, by the way. Minus b. Yep. ps of I minus b, where s is equal to where s is equal to actually we'll just go ahead and create a let's create the starting index because that's what we're getting again, the starting index. Starting index is map dot get ps of I minus b. So this will give us the index of where I found the ps of I. So that'll be the starting index. Our I will be our ending index. So we can just go ahead and say for int j is equal to s plus 1. Shouldn't be plus 1, s plus 1, because the starting index is plus 1. So we'll just say s plus 1. J is less than or equal to I. J plus plus. Rest of 0 is equal to a of s plus I. S plus I. So what this will do? We'll go ahead and say, hey, j starts from s plus 1, which is the starting point plus 1. As we determined earlier, that'll be the n I minus 1th element that it'll find it at. So we're gonna start from we have to start from I, which will be the first I, to the j, which we found, which is the first occurrence of the saying, hey, the minus 5 kind of comes here. That means like the total subarray's contribution was 5. Then you can go ahead and say, hey, s minus I, which is equal to that. Then return result. Okay, this should just return the result. So map.get b minus s will get the starting point. Starting j is I is the ending point, and which has to be equal to as well because it has to be at I. I is included, and we've got result. Cool. S just added to the map, or return minus 1. Okay. Dry run. I'm pretty confident. Well, let's dry run anyway. 1, 2, 3, 4, 5. What will happen? It'll create a prefix. Where is it? It'll create this prefix sum. Then, okay, fine. What it'll do in the hash set? It'll go ahead and say, hey, hash set starts from 0, 0. We have 1. Nope, we put it in. Do we have 3, which is ps minus b? That's not ps minus b. Okay, so we're just gonna put ps and I. Do we have 6 minus 5 somewhere? Well, we do have 6 minus 5. 6 minus 5 is 1. It's at 1. Okay, fine. We found that at index 1, which is going to be now our start point, plus minus plus 1 start point, which will plus 1. And then we'll go till I, which is right here, and we're gonna return the result, which is gonna give us 234. Is okay, I'm guessing, and we should be good. Let's key. My bad, contains key. I am not sure if you've noticed yet. I am not too smart when it comes to certain things. Contains key. Cool. PSFI is equal to B. Yeah. Oh, what? It does not get value? Um, hash map get Java. Yeah, get should work, right? Put. Yeah, hash map dot get. Oh, okay, right. The value isn't long. Oh. Oh. My bad. We forgot to change an important part of the thing. N-T-E-G-R? T-E-G-R? Integer? No, who knows? Comma integer, I-N-T-E-G-E-R, P-S, add, will be put, comma, I. Okay. Put comma integer, I'm pretty sure it's integer. Where we'll put, will result, we'll get PSFI, blah blah blah, hashmap.get, get the value, and we get that, we get the A, blah blah blah. Okay, fine. Oh yes. Mm, I think this should be fine. Can I not initialize an array like this in Java? I always thought Java was a bad language and we could do that. Hmm. Yeah. Can I not do that in the second line? Where? Uh, okay. I guess I'll do it that way then. This should be fine. Rest is not a variable that's been initialized. Yes, it has not been. I completely forgot of the size of the array, didn't I? Rest is equal to new int of I minus s maybe. Let's think this through. S is at a -1 instant, so yes, S will be fine. If we get an array out of a bound index, then I'm very shocked. At line 70 though, which is line 36, which is this one. Meh, +1. Okay, wrong trivial case. Why? Out of bounds exception. That means I'm doing something completely wrong. Uh, j is less than equal to I. It does not like going till 9 because so 4414 is expected. Um, what am I doing wrong here? J is less than I. Okay, let's just see. I'm gonna try and get the trivial cases wrong. No, it's just giving me out of bounds exceptions. Why? Am I crazy? That's the custom input. Let's get system dot out dot print line s plus quote unquote plus I plus quote unquote plus s minus sorry, I minus s or whatever, minus s uh yeah, okay, run custom test. 35 36. So if I saw the mistake, I saw the fucking mistake, didn't I? This is fine. S plus J. Yeah, yeah. S plus J. And that's also fucking weird because I just realized this is 0. And I was supposed to start res is I am I'm not doing well mentally, I think. I don't know why why did I mean this was just this was this was an eye-opening moment. Res is equal to J is equal to S plus J because if J is 0 it'll start from S and end at I. I am just very, very. It still gave me an out of bounds exception, and I accept that. Oh God. Less than size. Just do less than size. Okay. Now I'll be happier. How much time did I take on this one? I'm not even sure anymore, aren't I? I've been live for 36 minutes. This is literally horrifying. Yeah. Yeah, this was wrong answer. What? It was literally supposed to return the whole array. Why did it fail to return the whole array? It's less than equal to I. Anyway, that was my. Uh, I'm just disappointed. Okay, you know what? Let's just do one more and be done with it. Okay, maybe one more and we'll have a good time there. Okay, I'm gonna go ahead, chill with my dad after this. It's gonna be fun. Uh, let's see. Given an array A of integers and another non-negative integers and another non-negative integer k, okay, non-negative integer k, okay, find if there exist two indices I and j such that I minus j is equal to k. If not, that I is not equal to j. Okay, uh, fine. We can. God damn it! I think I know how to do this one. Um, let's see what are the possible things you have to go through. Okay, because I think yeah, you have to make a. So if you're going through all the subarrays, it doesn't make sense, right? Um, yeah, I think I know how to do this. Because the idea is 0, 0, 0, 1. Uh, let's take a 3 by 3, 0, 2, and then 1, 0, and then you'll notice that this is equal to this. So let's just take a consideration that hey, um, if I and this we don't anyway count. So we have to really go from I is greater than whatever, doesn't matter, and we have to count only the upper triangle to like see everything, right? And we will go ahead and that's one way to do it. Um, such that as yeah, so that means you have to anyway calculate the upper triangle. Okay, let's just take the upper triangle. Okay, we have to just take 0, 0, 0, 1, 1, 2, 1, 1, whatever. That does not really decrease our time complexity, but it kind of makes it so that we don't double check. Um, as we have to anyway return only minus 1, 0, we can also create a um, we have to do a of I minus a of j. So why don't we just like again, this is I'm getting highly reliant on this because it's the topic of the day. Why don't we just create a hash set where we go ahead and say, okay, first add 5, first add 1, not even hash map, we have to put a hash set. We'll just use a hash set. Okay, there is no dipping point over here because you have to again return 0 or 1 for this problem. Um, so they're saying 5 minus 3 is equal to 2 exists. All right. Um, so let's just take here. Um, so if if there is a problem where I minus j is equal to k. So that means um, we have to just check. Um, what can I do? What can I do with sets and hash map that can make it so that I can just find it more easily? What are the things that we do know? We can go ahead and say we can just put one. We can just put one in. We can check two. Uh, if you know A minus B is equal to C, so that means we can say A is equal to C plus B, right? A is equal to C plus B, right? So what if we kind of go ahead and put here, um, does K plus 5 exist? Okay, 5. So we know that, okay, the first one goes in, okay, no problem. The second one is, so we know 5 plus 2, 5, 6, 7. 7 does not exist, put 5 in. Then next one is 3. 3 plus 2 exists. 5 is right there. Return 1. Because 5 and 2 5 and 3 exist. That's one way to test it. I don't see a problem with that. So we can just go int n is equal to a dot length. We can create a hash set. Does anybody remember how to create a hash set? I'm gonna use this problem again because I don't remember how to declare a hash set. Sorry. Okay, it's a hash set only. Good God. Because I remember unordered list or unordered sets, and then I'm keep freaking changing between libraries and dictionaries and shit. So hash set of type. Do we need integer? Yeah, I think integer should be fine. Integer. Integer. Let's call it set, which is equal to new hash set of type integer integer. Okay, let's just initialize this. Then we can go ahead from for int I is equal to 0, I is less than n, I less than n, I plus plus. Um, if a set dot contains a of I plus um, b, return 1. Else set dot else set dot add a of I. So what does it do? Will this work for duplicates though? Because over here I and j will never be the same. So we should be fine. Even if duplicates exist, I and j are not the same. So it kind of counts. Okay, return 1, and then we can go ahead and return 0. Return 0. Okay, that's also one way to do about it, right? If a of I plus b contains, if a of I plus b exists, contains, then return 1, else add it to the set. And then return 0. Okay, let's check this out. I'm not happy. Okay, I guess fuck me. Okay, thank you. Okay, so return 1. Why? Why did my thing return 0? Is there a duplicates issue here? No, I don't see no duplicates. Mm, it does it want me to check backwards? Okay, let's see what could have added up to 60. Hmm. 90. Okay, 60. Let's find out the lower one of that first. 32. Hmm. Contains a of I plus b. Even in that case, it still checks till the end. So it should, if it like even if at 13, it contains, yo, if this plus b exists 60. I cannot even see where it is, to be honest. There is 63 minus 3. So if it's at 3 plus 60, oh yeah, should we sort this? Should we sort this? The sort might help. But then, okay, now think of it if you were supposed to like get an index. Hmm. Then what? Hmm. True, true, true. Hmm. I mean, I am looking it into a very different way, but I mean, we could always use a sorted array so that we can always go through the biggest to smallest. But we know that this is a good case, okay? So we know a minus b is equal to c, so therefore a is equal to c plus b. So what if one is smaller than the other? We should have to still check that case, right? Where, okay, there has to be a case that exists where, okay, fine. So I knew this was a kind of a possible case that I was coming through. Because 3 and 63, how do I do that? How do I calculate? Hey, 3 is already in the set, 63 just came into the set, and 63 plus 60 does not exist. Hmm. You know what? Let's just take help for this one. let's take help for this one because I do want to be out of here for a bit, and that's gonna be. Um, let's just take some help. Let's. I mean, it's all right to take some help. I believe so. I believe. Plus we're 41, 51 minutes in. I'm gonna probably do a few more sums later in the day, but those ones I'm not usually concentrating. So let's see what I can come up with till then, till he joins in. So how do I go ahead and check that? Uh, do I check else if? Like, should I just go ahead and just do simply as if? Minus b? Uh,
Oh, yes, yes.
hey, how's it going?
It's good. It's good.
I think I'm not sure if that will count as the answer of what I'm thinking, but I could really use a little bit of help here. Um, there's a simple test case, not simple. There's an absolute test case that I'm failing over here.
Mhm,
The question is as simple as it gets. Just find if there exists a situation where I minus j is equal to k,
Yeah.
where I is not equal to j. I did simple. I just said, hey, just check the set. I knew that if a minus b is equal to c, then of course there have to be a place where b plus c exists.
Mm-hmm.
So one of the test cases, like I'm not sure if this is the correct test case or not because I just like while I was waiting for you thought of it, like because there is a possibility that a b minus a of I might exist and that's why this is failing.
It would be P minus. It would be AI minus B, not P minus AI.
ai minus no ai will be bigger, larger than b.
Um,
Yeah, 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 yeah,
AI
yeah,
minus
yeah, right, right,
B,
right.
A, and
If
there
yeah,
would be two possibilities, right? AI minus B and AI plus B.
so this will also return
Then
one,
one.
right?
Yes.
So this should fix my test case, right?
Yes. Yes. Yes.
Okay, I know I'm extending this doubt a little bit.
Okay.
But say if the question was to also return the index, and I converted this into hash maps.
Okay.
How?
Okay.
Yeah.
Okay. So you can simply, when you are inserting into hash map,
Mm-hmm.
you can simply keep it index, like the key would be the value
Yep.
and the value would be its
Index.
index.
Yep.
Yes.
So I'll have to just make sure that in sorry about that. This is another
Mm-hmm.
one. So I'll have to just make sure when it is plus b, we
Yeah,
know
you can simply
that
return
we need to
set.
that the starting point will be at the value which is the first value
Hmm.
stored, and then the ending point will be
And
at the second,
I,
and
I
I'll have to reverse it on the other side. No,
so yep. Yes, yes.
got
In the
it,
second case, it would be reverse of that.
got it. Got it, got it, got it. All right, this helps. I'm just gonna submit it and see if I
Okay.
was there.
Okay, you missed something.
Oh, oh, I'm
But-
so sorry.
Hmm.
Test. I'm just gonna test it now. I'm just gonna test it first. Should test first.
Yeah. Okay.
I'm not sure if this affects too much on my look.
Yeah.
But yeah. All right. Thanks a
Yeah.
bunch. Thanks a bunch. I'm so sorry. I just figured it out as soon as I
Hmm.
messaged you. Thanks again for your time.
Yeah. Yeah. Okay. Okay. Yeah. Cool.
Good. Bye. God damn it! I feel so bad for him. Like I was like, I figured it out as soon as he fucking entered the call. Uh, poor guy had to waste his time. Anyway, that's all for today. I think I'm gonna chill. I will be doing. I will be going for a grind set for a bit because this is also increasing at a substantial rate at I don't like. So I'm gonna try solving. I do want to. I should have solved these two on. Now that I see the scores, I should have signed. I'm pretty sure their difficulties are much higher. No, this one is easy. This is the harder one. I'm I'm sure they'll be fun, and I really want to start really breaking through these ones as well. Let's see where I'm on the leaderboard today. I'm pretty sure I've dropped. Like I do. Oh, I went up. I'm at 8 now. My goal is to somehow get to at least number 2. If one like just for a day, I don't mind after that. Just one day number 2 is cool. Because the guy on the top, I think he's just written up some random ass. That's a very weird reputation points number, which I do not understand how he got. Because his problem solved percentage is also very low, so either they've been helping out everybody. This is interesting. Anyway, it's good to be done with 2 problems in an hour. Getting problem solved percentage down, I really want to kind of start having to reach a point where under 1 hour I can solve 4 problems, which is like 4 easy, 2 hard, like that. And I'm hoping that'll happen soon. Um, as I get more comfortable with the fingies, and it'll be fine. It'll be cool. It'll be cool for sure. Thanks enough if you guys took the time to do this.